Hello Linux lovers, my name's Wimpy, welcome to my world. Today we're going to be taking a look at Ubuntu MATE 2204 for the Raspberry Pi. Hopefully we'll be getting those final tests done. Good morning Popey, thank you for that. I'm going to run through the build script, how that works, how it puts the image together. I'm going to explain the new enhancements and performance improvements that exist in this release, and then that build script that I referred to I'm going to open source and make publicly available for the very first time, so a packed schedule. If you're watching this on YouTube after the fact, this was originally streamed live on twitch.tv/Wimpy's World. So if you want to join in these sessions interactively and ask your questions, then come and give us a follow on twitch.tv/Wimpy's World. Good morning, everybody. Thank you very much for stopping by again. Hopefully everything's working. Forgot to do an audio test this morning. I think it sounds fine. Larry, where did I get that? Amazon during lockdown. Yeah, I just searched for colourful lanyards on Amazon. So how's everyone doing today? Hello Paul, welcome back. King Egypt, hello. It's only a gnome, welcome back. The pre-stream audible ads, I can't control that. I can't control the adverts on Twitch. I do my best. I deliberately run a long ad run in that first 2 minutes whilst the stream is coming up, so it buys us I don't know, I think about 25 minutes of ad-free viewing. It's the best I can do. Hello, there's another Martin there. Hello, welcome back. So good news, made some really good progress on the final bits and pieces I needed to put in place for Ubuntu MATE 2204 for the Raspberry Pi. It was all about snaps. The way that snaps were seeded in the image for whatever reason wasn't working, and that is now properly working. So I'm going to run through all of that. So I think what we'll do is we'll start by dipping into where the image is. We'll get the image on a memory card. I've pre-built the image. Oh, that's the wrong screen entirely. Let's try this one. Here we go. So here's my card reader. Here's a card thingy. So we'll go and stuff this in the computer, and we'll quickly write the image that I built earlier today. Slightly, oh, can I get the end off? There we go. Slightly cautious because I haven't actually pre-tested this image. It should work, but there is a configuration change in there from what I've been doing recently. So let's just go here. If I open up a file browser and bring that down here, the way my build script works is I have this directory here in my home directory called builds, and here we go. We can see that must be an older image, yeah, from 2 weeks ago. And here's the image that I made earlier this morning. So we'll get that written out to the image writer, and we'll just get that done. Put my password in. This shouldn't take too long. And then I'm going to be using the test, the dev environment that I've got set up there. So that's in a Raspberry Pi and a Desk Pi Pro. Good morning, Esme. Welcome back. So we'll just let that write out. So these images are slightly bigger. They're now up to 9 gigabytes. I think what I'm going to do is, providing this image works, I think this will be the release, which I'll then have to, put out probably tonight, because I'm going to have to generate the ARMHF and ARM64 final builds, and that takes a while to upload. There's one change I may potentially make in how these images work. I'll explain that, but what I think I'll do is release it as it is, and then when we do a point release, the 2204.1, which will be coming up around August time, hopefully if I'm going to make these changes to how swap is enabled, I'll do that for that later release. But I'll talk through some of those changes because I'm quite happy with how swap works. It's got an optimized swap system in this release. So that's going to take a few minutes longer. So the other thing we can do is quickly bring up the editor. So here's the build script here. I'm going to walk through this a bit later, sort of explain how these steps work. If you've ever seen any of my streams about Retro Home, which is another Raspberry Pi based OS, the Retro Home build script is derived from this one, but this one has never been publicly released before, and it has a bit more to it. Like I say, it can manage preceding snaps, for example, which is let's say it's a fairly complex process. So this will hopefully be of use to other people who want to make Ubuntu derived Raspberry Pi images. So how's our write coming? Is that done yet? Looks like it's done. Okay, so let's eject that, turn this off. So what we're going to do is we're going to start with actually booting the Pi off this image. So let's take the old card out and we'll put this new one in. We'll switch to the capture view and we'll turn the Raspberry Pi and we'll see how it goes. Oh, it's me. Thank you very much. That's very kind of you. So it's a good first start because that's the colourful bootloader screen for the Pi. Oh, there we go. I was a bit concerned for a minute there because it wasn't changing, but it looks like something else is going to happen. I'm just going to bring my keyboard over whilst this is booting up. So I've got a black screen for a long time. This is not look. There we go. Phew. Okay. So whilst that boots up, let's just do here. So I've got this wireless keyboard and wireless mouse. This has a single USB dongle in the back of the Raspberry Pi, and this just makes it easy for me to put the keyboard and mouse out of the way and grab it when I need to do some work on stuff. So let's see how this is coming up. The first boot is a bit slow because it goes through that initial configuration. So you will see the OEM configuration screen in a moment. It'll ask you for usernames and passwords and all of that good stuff. And it takes a bit of time, particularly on SD card, to generate the local indexes and things like that. So that first boot is a bit clunky. Well, it's not clunky, it's just slow. But once that's done, the performance is really good in this release. So Paul says, MacBook in the office. I go downstairs to the kitchen and could still hear the stream with no loss of signal. I love my AirPods. Yeah, I do wireless earbuds as well. Hello, Luke. How are you doing? This is taking much too long to start up, which suggests to me something's not working. Oh. Yep, there's a whole bunch of stuff that's not working. Network. Okay. Failed to start the hostname service. Well, that's bad. Why? I told you this was a bad idea, didn't I? There's me saying, oh, it'll be fine. We'll just do this testing. I had an image that I tested last night and it was fine, and now this. So why is this not working? I tell you what we could do. We'll leave that there, and I'll go here. We'll actually generate a new image. So the build process is largely cached. So what we'll do is we'll pick up the build process from a point at which it should be mostly cached. So let's go to actually, I think I've got this stuff all in the wrong place. So let's we'll just bring up the code editor. So down the bottom here I have the stages, and I'm going to make this dynamic at some point in the future. So the bootstrapping stage and the installing the desktop stage are about the most intensive. So what we'll do is we'll just rerun the snap kernel config clean and image stages again, and that shouldn't take too long. So let's do that, and it will pick up from the point at which the sort of the root file system has been generated with most of the packages. So we'll let this go. Oh, Linux Paul has upgraded to an iPhone Pro Max. How are you finding it? I just went for the 13 Pro to keep the size down a little bit. So the bit that's running at the moment, this is actually preceding the snaps in the image. We'll go and look. In fact, whilst this is running, I could in fact talk through how this script is working. Let's go and see if this build is. That's still not booting, so that's bad, isn't it? Okay, well we'll let this new image generate, and whilst it's doing that, let's take a look at this script and sort of look at how it works. So I've got these stages here: bootstrapping, installing the desktop, seeding the snaps, installing, configuring the kernel, doing some general system configuration, cleaning up the image, and then actually producing the image file that you flash onto a USB stick. So if we just head up to the top of the script here, we'll go through sort of how some of this works. This is just a helper function to sync the caches from one step to the next. And this is a wrapper function that I've written. So behind the scenes, this uses systemd nspawn. So it uses a systemd container, and it actually creates an ARM container on my x86 workstation, and then uses QEMU system static to do syscall translation, so that I can build this ARM container on my fast Intel or AMD based workstation. So this is just a wrapper, and I run apt cacher on the build machine, which is actually my workstation, and that's so that it doesn't have to constantly keep reaching out to just download packages. It actually has the packages cached locally. So that is used to basically jump into, we'll see how this is used, jump into the container and then run things inside the container in order to construct the image. This is another helper function that basically precedes a snap, and I call this again from another function. So I see Popey has also got an iPhone now. How are you getting on with it? So you've gone for the iPhone mini, iPhone 13 mini, which is what my wife has got. I think it's a shame they're not going to keep that form factor going. It's the only decent compact phone I could find. One of the reasons why we went to iPhone. Paul says he's got sausage fingers. So let's have a look here. So Popey asks a question. Let's just bring that up. So Popey says, hypothetically, could you run the same script but change the architecture to AMD 64 and build an image for a laptop? Almost. There is some specific bits in this at the moment that are very much geared towards producing a Raspberry Pi image. But yes, and I intend to do precisely what you've described, is make this script a bit more adaptable so that you can use the same script to build an AMD 64 image instead of an ARM image. And I want to do that for Retro Home because I would like to have a PC version of Retro Home. So it's not going to be too much work to do that, but it does require a little different because of the way that the bootloader works for ARM devices and things like that. So there's a little bit of nuance that needs adapting, and I will do that at some point with Retro Home. Right then. So you're very happy with your new phone, I think. So this is another helper function. We'll come back to that in a moment. So if we look at the stages, here's the stage 1 bootstrapping process. The first thing it does is install everything you actually need on the build machine in order to complete a build. So it's basically deb bootstrap and git and the systemd container tooling. We then determine if apt cacher is present or not and set the repository accordingly. And then we use deb bootstrap to stand up a first stage bootstrap. And this actually has some specific steps in it, particularly this one, And I think I've got some comments up here about how we install the Cloud Guest utils. So these are tools that are used to automatically do the file system expansion. But I found that if you didn't seed them in a very specific order, you actually end up getting all of QEMU for x86 inside the Raspberry Pi images, which is what I see in the Raspberry Pi images for the official Ubuntu builds. So I coerce this process to actually try and keep those things out of the image and keep the image size down and a bit more relevant, and consequently without that extra stuff it runs a bit better too. We configure our repository, we set host names and what have you. We do an get, upgrade, dist upgrade, all of that good stuff. We then install this utility here, which is actually what is responsible for doing that automatic file system growth on first boot. We install the standard Ubuntu user space, and then this is a package that is from the official Ubuntu project, which includes some default settings and UDev rules and things like that for Raspberry Pi. So we install that, and then we clean up after ourselves. So this is really standing up what you would consider something a bit like the server image. It's just the command line tools for the user space, no kernel at this point. Stage 2 is the desktop. This is super simple. So we install the tasks for Ubuntu MATE Core and Ubuntu MATE Desktop. So once these two tasks have run, it effectively has in that root file system the Ubuntu MATE Desktop experience. So that is everything that Ubuntu MATE provides in those two packages. And then we land one configuration change. And this is to tell NetPlan, which is installed by default in all Ubuntus, to actually not manage the network and hand off all network management to Network Manager, which is what's used in the desktop environments. And then this here, for the very first time since I've been making Raspberry Pi images, this is the first time this is no longer required. So due to the improvements that the Ubuntu team have made, and also this is in collaboration with the Raspberry Pi engineering team, due to the improvements that have been made in using the full KMS driver now, I don't need to turn off compositing by default. We actually have a fully accelerated desktop experience now, and hopefully if we can get that image to work, I'll be able to demonstrate that, and that's particularly noticeable in watching video, full HD video playback with things like YouTube, which traditionally have been a bit janky but now work extremely well. So this is no longer required, so that can actually be deleted. Stage 3 is snaps. So there are some snaps that are shipped by default in Ubuntu MATE. Here they are listed here: Ubuntu MATE Welcome, the software boutique, an Ubuntu MATE Pi helper utility, the Snapd desktop integration, the common themes, the GNOME runtime, and then Firefox. So this is what you would find on the desktop, on the PC version of Ubuntu MATE. And what this function does is set up all of the assertions to enable the device and the model, basically as a generic classic image. And then it what's called precedes each of those snaps. So we use this precede helper function to basically say, go and get that snap from this release channel and put it into the image. So it does those for each of those. It then introspects them slightly to see what base image each of those snaps requires. So there's base images that are called like Core 18 and Core 20. There's one even called Bear. So it works out if a snap requires a base image, and if it does, it installs those base images. And it also installs the Snapd snap under the conditions where that is required. So each of those gets pulled into the image. And then we have this funky bit here, which is what I had to work out a couple of nights ago, which is then validate the YAML for the preceding of the snaps. And then we bind, so because we're building this inside a systemd container image, we can treat it a bit like a chroot. And this snap precede utility actually operates on a chroot. So at this point, I'm no longer using my nspawn helper function. I'm mounting up the various file systems by hand, like an animal, in order to create enough of a functioning ch root so that we can run this snap pre-seed utility, which is actually run from outside of the image. So it runs on the host and it then introspects that image, and effectively it installs those snaps that we preceded. So it does all of the hook, stand up, and all of the connections for the security model and stuff like that. So, and then after that's run, we then unmount all of those things, because this is the only time we need to do this. So we just carefully reverse unmount those things, and then we run the AppArmor parser. I'll be honest, I don't really fully understand what this does, but I know it needs doing. So snaps have AppArmor rules and profiles and what have you, and this basically recompiles all of that, I think, is what's going on there. So at that point, we now have a root file system and the snaps all pre-installed and enabled. So that's what we have there. I just need to flip a different window back over. Here we go.
Thank you for the follow, Alokar Sade.
Thank you very much for the follow. So next we move on to the kernel stage. And this is the kernel and the bootloader for the Raspberry Pi, basically. So we drop out a README file. These can't be packaged because these are obviously going into the FAT file system that is the bootloader. We drop some configuration in based on whether we're building for ARM64 or ARM HF. We then drop out the config file for the bootloader. This this has been changed slightly in compared to recent versions, but the big difference is this now that the full KMS driver is enabled, which means the Raspberry Pi now works like a contemporary Linux operating system, in that it doesn't use any of the Diskman X stuff for the display. It uses all the regular protocols, which now makes it much easier to work with from my point of view, because it works like, you know, any other operating system that I would build for Ubuntu MATE. There's a couple of changes here. So we update the initial RAM disk or the initial RAM file system configuration to tell it to use LZ4 compression or to enable LZ4 compression and what's called Z3 fold. And this is so we can enable Z-swap, which is compressed swap. So this means that we can allocate a 1 GB swap file on the disk, or the SD card in this case, but it will actually be able to hold more than that amount, probably about 1.4 gig in total. But what's really important is, because it's compressed, it's faster access because it doesn't have to move as much data across. So this is all enabled by default. And the thing that I may change about this in a future iteration is, instead of creating this swap file inside the image at build time, I may replace this with some systemd units to create this initial swap file on first boot, and then do the mounting of that swap file through a systemd mount unit as well. So, but for the moment, I'm happy with this, in that it did work when I last tested it, and it works well. And I could confirm that not only was the swap enabled by default at all times, but the correct options were present and working. Let's just go and see how that build is working. That's over here. There we go. We've actually got a new build. So I think what we'll do is we'll go and stick that on another SD card, and we'll see how that goes. And whilst that SD card is writing out, we'll look at the next piece in the build script. So we'll just plonk that in there. Did I leave the file explorer open? I think I did. Here it is. Oh, I missed it. Oh, and again. There we go. Right then, let's just cancel that. And here's our image. Open with the disk image writer. That is the right words I'm looking for. And put that on that drive there. Start restoring. Restore. Put in my super secret password, which is not test, by the way. On this occasion, one of the few occasions where my password is not test. So I see there was a couple of questions. So whilst this is writing out, so Paul says, let me just do this. I see there's a couple of questions. Paul says, I need to get a Raspberry Pi. I could make that my Linux nerdy machine since I don't have a Linux installation right now. Yeah, it's a good choice. They were in short supply. I don't know if they're still in seriously short supply or not, but I did hear a number of my friends who were trying to get them recently and could not find them for love nor money. I don't know if that has changed in the last couple of months or not. And then we have a question here from, how do I pronounce this name? Hello, Sir Sade? Can I ask why you're not using live build from the Debian team rather than using your custom scripts? It's mostly because this script is kind of something that has evolved since the very first scripts I created in 2015 when I first made a Raspberry Pi image based on Ubuntu MATE. And frankly, those live build scripts are a bit cumbersome to work with. At least I felt for the purposes of this project. So I created initially those scripts way back then. We're using CH roots to build all of this. And then I moved it over to systemd nspawn because it was a lot more reliable. It's just fast, it's uncomplicated, it's easy to work with. So I'm sticking with it. Now, as it happens, I used to work at Canonical and did a lot of the work to bring up the desktop image for the Raspberry Pi, the Ubuntu desktop image for the Raspberry Pi while I worked there. And it is in part based on these very scripts I'm showing you now, but integrated into live build. And the Ubuntu team are now opening up to the community flavors the ability to have the Ubuntu official build system automatically create Raspberry Pi images for projects that want to opt in. So I will likely move to that. But my other Raspberry Pi based projects, I will continue to use this build system because it also gives me the flexibility to easily switch between building a Debian based image and an Ubuntu based image without having to switch underlying distributions and things of that nature. They're very flexible. I'm quite happy with them. Hopefully that's a sufficient answer. So hello said the Ubuntu team has their own official build tool as well. Yes, it is. It's Ubuntu uses live build and live CD FS live. I think that's the name of the project. In fact, I can find out because I did make a note to one of the tools in the notes. And I'll just look at this. So King Egypt says, do you think those ZSwap improvements will migrate into the main x86 Ubuntu images as well? I don't know. So it's interesting because I got the idea of doing this ZSwap enablement from a blog post on the official blog that talks about how this is what was done in the Ubuntu desktop 2204 Raspberry Pi images. And they spell out, well, this is what you want to do if you want to enable this on an older version of Ubuntu. So that's how I integrated that into my build scripts. But when I was actually testing the Ubuntu 2204 images, although they say ZSwap is enabled by default, it's not at all. In fact, swap isn't even enabled by default. So I think there was an intention to do it, but something's fallen between the gaps. So maybe that will come in like the point release later in the year. Maybe it's a bug that just didn't get fixed in time. I think there's less of a need for it on the full desktop images, but it's trivial to enable on desktop. Maybe I'll do that as a separate video one day. Turning on ZSwap on regular Ubuntu. It's literally takes moments. It's time. Is it time for a Raspberry Pi 5 yet? I'm going to say no. I think the Raspberry Pi 4 with 8 gigs of RAM is... We're just getting to the sweet spot now where there's enough enablement with the new full KMS driver that it's almost like getting a Raspberry Pi 5 because the performance improvements are really paying dividends there now. Right then, so I've put that image on the card, so let's go and grab that. Let's just see. Did it get anywhere? No, that's a dead image, isn't it? So we'll turn this off. We'll forcibly shut down this box. Eject that card, and we'll put this fresh one in. Right, we'll turn it on, and we'll go back to the capture for the Pi, and we'll see what happens. So, well, that's good. It's found the bootloader. I really hope this works, because if it doesn't, I've broken something, and I'll be hard pressed to know what it is, because these images I was testing last night and they were definitely working. So let's see what we get. Black screens for a long time is never a good sign. Let's see how we go. Okay. I wonder if I've broken my network here, because I did explain yesterday I have on Monday a bit of an unusual network configuration. So we've got this question here from It's Only a Gnome. What install file system encryption options are available out of the box for the Pi? For the desktop, I always use ZFS. So these are what we would call a pre-installed image. So the image that you stick on the USB card has the file system, enabled. This is good news. Hey, clearly there was something wrong with my previous build, because this is obviously looking much better. That's good. I can breathe easy now. So for these images that I'm preparing, the file system is ext4. There's no compression, and there is no encryption enabled in that file system, so it's just regular straight up ext4. In the past, I did used to produce 2 variants of the image, one with ext4 and one with the F2FS file system, which is a file system created by Samsung specifically for solid state and flash memory based devices. And I'm considering doing that again. Maybe I'll just do it in Retro Home though. I want to keep these desktop images for the Raspberry Pi as close to the Ubuntu desktop images as possible. But for Retro Home, I may switch to the F2FS file system in order to eke out a little bit more performance. So this is good. This is going to take us through the first configuration. Excuse me. So it is a UK keyboard. I'll just move that one out of the way. We'll have this. Whilst this, I'll go through these steps by hand. Create my user account and what have you. So I am Martin. We will call this Jammy Pi, and my password is test, by the way, and there we go. We'll let that run. So this will take a little while to configure the locales and rebuild the initial RAM disk and stuff like that. So while that's running, we'll flip back here and we'll take a look at the remainder of the build script. So there we go. This is, as you can see, here's the FS tab, and you can see I've got this option here, and this is what triggers the file system growth on first boot, which we can check when we look at this image that we're building at the moment. Then we install all of the stuff, which is basically, you know, the Raspberry Pi kernel and kernel related stuff, basically what you could call hardware enablement. So this is very specifically what needs to happen to bring up a kernel on the Pi, and then it shuffles some files around dependent on whether you're building this image for ARM-HF or ARM64, and that's to put all of the right things in all of the right places in the file system so the system can boot. So that's basically what happens there. I think it's relatively straightforward. This is probably the only magical bit in here, which is kind of assumed knowledge. You just have to know this is a thing that needs to happen, but I should probably comment that a little bit better at some point. Then we move on to the configuration stage, and basically this is a very specific thing. You'll have seen as we brought up the image here, we're inside this, you know, first boot configuration wizard. This is like a piece of Ubiquity, the Ubuntu installer, that is just designed for OEMs. So we've effectively put the Raspberry Pi image into the OEM configuration state to take us through this first boot experience. And that's what this piece does here. So we create the OEM user account. This is the user account being created here. We then install Ubiquity and the OEM configuration engine for Ubiquity. And then this is just some inline hacks, monkey patching basically for Ubuntu MATE to work around a bug. And then we stand up some directories and some you know, bits and pieces in var. And then we tell the image that it's being put into the OEM configuration prepare stage, and we enable the various system D units. So that basically then tells the Raspberry Pi you're in a configuration state, so when you boot, go into that first run wizard, which is what's happening right now. This is super simple. This is basically go down the image and delete all the cruft out of it, anything that we wouldn't want in the image because it needs to be pristine. And so that's that step. I did see there was another question here. Yeah, so it's only a GNOME says, other than home play use, encryption is a must. It's difficult because how can I ship a pre-installed image with an encrypted file system and have a different key for everybody that downloads it? It's kind of a difficult problem to solve. And also there's some overhead there on the Raspberry Pi where certainly the older models don't have the necessary instructions to actually handle that encryption well. So it's best to, for performance reasons, best to turn it off. But I think most people treat their Raspberry Pis as, you know, fun box devices. So King Egypt asks, does F2FS increase the life of the SD card versus X4? Or is it just performance? I don't think it helps with the longevity of the devices. Certainly those sorts of concerns are from yesteryear. The sort of endurance of SD flash based devices are significantly better today than they were 5 years ago, and that's true of SSDs as well. It is about performance, but actually even that performance gap is narrowing as well, which is why I'm gonna actually have to think carefully and do some measurements to determine if there's any benefit. When I did used to produce F2FS images in the past, there was definitely a significant performance benefit versus X4, but X4 has got a lot better in recent years, particularly in how trim works, which was where the bottleneck used to be. And then Popey asks, where is this script source hosted? Right now, it's in a private GitHub repository, but by the end of this live stream, it will be in a public GitHub repository. So I'm going to release this script at some point during this stream, and it will be publicly available for the first time. And that's really so other people can use it and learn from it and create their own projects with it, or forks of it at least. And it will be under an MIT license. Hey! Now, here we go. So this is, I'm going to guess this is Dave. Dave, this is Dave, right? Dave Jones, Dave. And if it is, please let me know, because otherwise there's a name collision here. Yes, it is. Hello. So Waveform works at Canonical on, well, I assume you're still on the Foundations team, and is the Raspberry Pi guy at Canonical for Ubuntu, and has been very active in the Raspberry Pi community for many years. And it was Dave and I that worked together to sort of stand up those initial Raspberry Pi images for Ubuntu Desktop. And Dave uses the Raspberry Pi 400 as his daily workstation for the work he does at Canonical, which I think is pretty amazing. And one of the reasons why these images work so well now is because Dave daily drives Ubuntu Desktop on the Raspberry Pi. So you know, we should all give Dave a round of applause for the improvements that he's been making in recent years. I'm going to just bring that back up. So Dave says, on the subject of shipping encrypted on the pre-installed images, Lux can do on-the-fly encryption, yeah, of the existing file system, so it would be theoretically possible. Yeah, I agree it is theoretically possible. Tell me, Dave, what do you think about this? My fear is that some of the older Raspberry Pi devices wouldn't handle the encrypted file systems as well. It may tax them too much, which is why I've steered away from it. Am I right about that, or am I dead wrong about that? Is there enough instruction set support in the older devices to handle that well? And James Harking says that their understanding is that F2FS is better than X4 for longevity. Okay, so thank you for that clarification. And so Dave, whilst you're here, I don't know if you caught it, I was talking about ZSwap in these images, and I noticed that in the official Ubuntu Desktop 2204 images, that ZSwap stuff isn't working by default. In fact, swap is disabled by default in the images. I think there's a bug there. I figured this out the other day whilst I was trying to implement the same thing, which I do have enabled in this image. I'll catch up with you on IRC and we'll figure that one out. Yeah, so Dave says that on the older devices they're probably a bit slow, and the performance hit of an encrypted file system would be noticeable. Yeah, so it's doable, but you know, be aware of that. And certainly it's why I've steered away from it, because I don't want to hamper performance and also run the risk of overheating the SoCs and what have you. Right then, and thanks very much for joining, Dave, because you are literally the authority on this topic. So Dave says that he's using the Pi 400 on an SSD, and they're fine with Lux encryption in the background. Actually, yeah, so I was saying that you are daily driving the Raspberry Pi 400 as your, and you've got a whole blog post on that. Dave, if you want to share a link to that in the chat here so other people can go and learn from it, please feel free to do so. If it doesn't let that through, I'll clear that in the chat, because I read it the other day and it was a fascinating read, and I was like, yeah, this is what more people should be doing, is actually, like, you know, really properly dog food this stuff. Right, let's just go back here to where this install was running. So I say install, that initial configuration step was running. So that's completed and I'm presented with my login screen. So my password is test, by the way. So let's log in, and we will be at the desktop momentarily. And this is the very first time that I'm bringing the this is the very first time that I'm bringing up an Ubuntu MATE image on the Raspberry Pi since I first started doing this in 2015, which has the compositor enabled by default, and it doesn't suck. If you're seeing any sort of ghosting, that's because this is running through an HDMI capture device, and so that will be where any weirdness is coming from. But this is something I've always had to turn off, and it's fantastic that is no longer a requirement. So I see some other questions, some other commentary from Dave, so I'm just going to come back to this. Let's have a look here. So It's Only a Gnome says, does the script create the SD card image? Yes, it does. It actually creates the image file that you put onto either a USB stick or an SSD or an SD card, and then the Pi can boot off any of those medias. Why not have custom script that can be run by the user that allows selection of file system? Because you have to provide the whole image. It's not like a PC where you boot off something and install to something else. I mean, it could technically be possible, thinking about it. Could have something that boots off the SD card and then installs on an SSD or a USB stick. I'm not going there. That's more work than I'm prepared to undertake, but technically I imagine that would be possible. Dave says on ZSwap, it's not active on the server images, okay, but it should be on the desktop images, but I did make a boo-boo. Yes, so I noticed that those modules are missing from the initial RAM disk configuration, but also I saw the systemd units that actually bring up the swap file. But I've never seen the swap enabled when I've been using the official Ubuntu desktop images. I've taken a shortcut in that I create the swap file inside the pre-installed image. I'll just show you very quickly what I'm doing here. And I know I have some freedoms here that you don't. But here we go. This is what I do. So I poke those inside the initial RAM module configuration, and then I actually create the swap file inside the image rather than relying on systemd units. I was saying earlier, in like 2204.1, when I refresh these images, I may move this to an entirely systemd based configuration where systemd is used to create the swap file and mount the swap file as well, rather than doing this actually have a fixed entry in the FS tab. Right then, let's move back over here because we've got a desktop. I'm actually going to restart it because there is a bug that I'm aware of, which is we've booted into this sort of pre-execution environment to do the initial setup. That setup completes and then we log in as ourselves, but at this point snaps don't function, so this is like a bug I'm going to have to note in the release notes. So we're just going to restart the Raspberry Pi so that it comes up like for the first time with everything properly enabled. So let's have a look here. Oh gosh, I see so many questions. Let me just okay, so Dave knows that this is a bug, and it looks like I'll catch up with you on this one, Dave. Hello Mark, how are you doing? Good to see you. Wobbly windows by default, it would be possible now. I mean, technically I'm not going to do this today. Maybe I'll do this on Friday for funsies. It should be possible to install Compiz, which still has all the MATE integration, and get wobbly windows on the Raspberry Pi. Let me know in the chat if that's something you want to see. We could do that for fun. Hey Tommy, welcome back. Yes, so Tommy, on this topic here, I have been talking to NixOS developers. There is definitely going to be NixOS related stuff on here in the not too distant future. And also for work, I stream on Slim DevOps. So that's here on Twitch as well, twitch.tv/SlimDevOps. If you get subscribed there, I think we're going to have the Nix, at least one of the Nix developers on there first, but I'm going to have them on here too. And also they are going to join us on the Linux Downtime podcast, which is a podcast I've recently started doing with my friend Joe Ressington. So linuxdowntime.com, I think, if you want to go and get subscribed to that. And we recorded this week's episode last night, and Kyle Fazzari was back joining us to talk about what is a Linux distro anyway, and also Hayden Barnes of WSL fame, who's now at SUSE. He also joined us for that discussion. So, I'll just catch up on the messages here. Yeah. Okay, so Dave's just commenting on what I was saying about about the swap stuff. Yes, Tommy, Hayden is awesome, and it was a fab conversation last night. I think Hayden will be joining us in the future as well, because he came up for a topic for a future podcast, which I think we'll be recording in 2 weeks. So Hayden, I think, will be joining us fairly regularly. And Dave says on the installer for the Pi, one of the things that at least suggests against that is the Pi Beta boot firmware now supports flashing a blank. Ah, okay. Basically, downloads and runs RPimager locally from RAM. Ooh, isn't that nifty? So the trick here then is to get yourself in the get your operating system in the RPimager JSON tree so that you can utilize that capability, which I know Ubuntu enjoys that. But I don't think Ubuntu MATE is in there. Maybe I'll reach out to my friends at the Pi Foundation, or maybe you, and you can help guide me, because my information's getting a bit out of date on this. Right then, anyway, let's do some quick testing here. So my password is test, by the way, so we'll just log in, and I'm going to move the other mouse out of the way so I don't confuse myself. Oh, there we go. Very good. That was Paul. Very well done. That's the appropriate redemption for my password is test. So let's change a few things. In fact, let's not change anything. Let's do this. Let's start up Firefox, because this is going to take a while, because this is a snap by default. So we'll just let this do its thing. The first run is a bit slow, so we'll get that up and running. It is still, let's just do this and do that and do. Is it in there somewhere? It should be in there somewhere starting up, shouldn't it? I don't see it. Oh, there it is. There it is. So, oh, here we go. And it has actually popped up in the background. So let's just close down a couple of tabs that we don't need. Let's get rid of that one. Let's mute this one. You'll see why in just a moment. I need to bring up a different view on my workstation here, because I need to make a note of where I'm going. I'm about to go to YouTube, and I'm being very deliberate about it so I don't run into any unnecessary copyright claims. So I'm going to go to youtube.com /Blender Animation Studio. Gosh, okay. Accept all, whatever. Just do it. Just do as you're told. Let's make that a big old screen. So it's still muted, and what we'll do is we're going to open up this video, this is the one that I've used in the past, in past versions of Ubuntu and Ubuntu MATE, to look at the performance. So we're going to open this up here. We'll turn the captions off because we don't need that. We're then going to go straight into, we're going to be super brave here, we're going to go straight into 1080p. We're going to bring up the stats for nerds, and then we'll full screen that, and we're actually going to see how this does. So we should see some drop frames as it adjusts. There it is, but now it's no longer. And let's see, how's this going to handle? Is this dropping a lot? That's fairly okay, I think. And again, some of this you're going to be seeing some stuttering because of the way I'm capturing this. So that is better than I've seen it for 1080p. In the past it used to be extremely stuttery, and we're only seeing a few frame drops now. So watching full HD video is definitely doable, and I think if we drop this back down to 720p, which is probably a slightly more reasonable expectation, we should see that this will run without issue once it's all caught up. There we go. So it dropped 25 whilst it was switching resolutions there, but that seems fairly consistent now. So this is a significant improvement, and this is directly as a result of using the full KMS driver now, and a contemporary display server stack using all of the usual protocols and drivers and what have you. So this is significantly better, and probably the biggest single improvement. I think what I'll do is at some point I'll do a video on how to install the Vivaldi browser, including the Widevine module, so that you could watch, say, Netflix, for example. So there we go. That's a good test of the improvements. And if we just clear this, so let's do it on the right. Let's do it in the right terminal. Let's make this a bit bigger so everyone can read it. If we do this, we can see here that swap is enabled just fine. So I'm pretty happy with this image, and then if we do a snap list, we should see all of the snaps that we preceded. We know that Firefox is working, so we know that the snaps are there. I'm assuming that welcome works, although I have had reports that that's been crashing for people, but not on the Pi, just generally. So, there we go. No, that seems to be fine. And it knows it's running on a Raspberry Pi and presents that specific information. So this is all looking good. This is all looking good. So let's just see. I'll just catch up with a couple of the messages in chat, and then we'll conclude our little look at the build script, and we'll get that thing released. And so I'll share where people can get to all of that stuff. Okay, so Dave, first of all, thanks very much. I will contact you to figure out how I can get in touch with the right people to make that happen. That would be fab. Thank you very much. And just be okay. Let's have a look here. Need to have a play with the new Pi bootloader stuff. Yeah, I think that sounds interesting. I'll have to take a look at that as well. And Tommy Luco says, by the way, Mate is fully supported on NixOS and is super easy to install with the new installer GUI. I know all of these things to be true because I've been testing this stuff in a VM in order to figure out what my sort of configuration is going to be. I'm going to be installing Nix as the full-time distro on my laptop, but I'm doing my due diligence, and I'm also figuring out where it is I might want to insert myself into the NixOS community to work on some, let's say, rough edges that I've encountered with the way that Mate is implemented in Nix. Not to say there's anything bad with that, but I mentioned on Monday I'm doing a bunch of work for Mate enablement in Debian and Ubuntu Mate. So Debian Mate is going to become almost identical to Ubuntu Mate in every way, and that work is going to roll over to a SUSE variation as well for a project for German municipalities, and I would like to implement that same default experience in NixOS as well. So that's sort of where I'm headed with my interest in Nix. Hey Adam, how you doing? Welcome back. What's good? Ubuntu Mate 2204 for the Raspberry Pi is good. That's what we're looking at right here. And I see there's some questions here. So, do you have any Office software on your Pi 400? So Dave, you're going to have to share that blog post because I know you talked about like what works for you and where the gaps are in terms of support. Okay, so we have a working image. This is good. So I think what we'll do is we'll just head back to here. And I was talking about the kernel enablement piece in the build script, and we got beyond that, and we were talking about the fact that it does a little bit of a cleanup. And then at the end, you know, people were asking about the file system. So this is it. This is the bit that actually takes that container, because we've built the image inside a container, and then turns that container into an image that you can actually put on your SD card or your SSD or USB stick or whatever. So here we go. We create a FAT32 partition. We create an X4 partition. We rsync all of the stuff from our build tree into those things, and that's it. You know, I won't spell this out, but it's basically take everything that's in that container and copy it into an image that we create, and then here's a step that I haven't run yet, but compress that image with XZ to make it smaller to upload and sign it. And I haven't been running this step because I only do this when I actually release the images onto the Ubuntu MATE website. So I think that sort of, and then here's the basic configuration. So what I will do after the fact is I will regenerate these images for ARM64 without beta 1 in the name, and I'll generate another one for ARMHF, so both are available, and then I'll be able to get those uploaded to the Ubuntu MATE website. But I think what we'll do now is I'll go and show you where this script lives. In fact, let's make our one configuration change, because we now know that that worked. So we no longer need where is it, that commented out piece. We no longer need this. So we're going to drop this entirely from the build script because we know that's not necessary. We'll move over to Git Kraken. We'll get this pushed up. So let's stage that. Drop no longer disable the compositor. The full KMS means the compositor works correctly. Okay, oops, get rid of that. And then we've got another change here where I had to just bump the size of the image ever so slightly because the installer was complaining that there wasn't enough free space during that initial build. So let's just bump the image size slightly. Prevents the OEM config from complaining low disk space. So those are the two changes. I'll get those actually pushed up to the repo. This has lived in GitHub for some time. I don't know quite how long, but what we'll do is go and make this GitHub repository public, and something I'll need to work on. So here it is. As you can see, it's currently private. It's in Wimpy's World Ubuntu Pi image. So we'll go into the settings.
Thank you for the
this
follow,
repo.
Waveform80.
Thanks for the follow, Dave. I appreciate that. And somewhere down here, I think there it will see whether it's public. Nice. Appropriate use of the channel point redemptions there, Popey. Very good. Change visibility. There we go. So let's make this public. And I need to put that text. Oh my gosh, I can't see what I'm doing because the filter cucumber has been invoked. That will take but a second. I literally can't see what I'm doing when that's running. It completely overtakes my system. There we go. So let's do that. Put that in there. Change the repository visibility, and I'll put a link to this in the chat, and that should now be publicly visible. So There we go. There it is in the chat. So I think there's a couple of questions just rolled in. So let's got to keep up somehow. Very good. Let's have a look here. So it's only Gnome says, I think something like sudo apt install Chromium browser might get you going. Yes, except in Ubuntu that will be a snap, of course, and I'm not quite sure how you enable the Widevine DRM module inside the ARM version of snapped Chromium, which is why I was talking about Vivaldi, because that's available as a deb, and I do know how you enable Widevine in that. So yeah, that'll be something I cover, because I'm thinking about using what's the word? Thinking about using Vivaldi in Retro Home. I'm actually going to contact Vivaldi and see if I can get the rights to redistribute Vivaldi pre-installed in Retro Home to create that minimal desktop. And if you're curious what Retro Home is, that's what's coming up next. I'm going to get these builds done for the Pi. I'll be streaming again on Friday. I think on Friday I might do the GPD devices, the 2204 builds for the family of GPD devices. I think my backpack is big enough to bring all of them in, and I can get them all out on the desk and go through each of them in turn. And then next week I'm going to do Retro Home stuff, which I know Takov, who's just joined us in chat here, has shown some interest in getting involved in, specifically porting the GPIO drivers for the different cases from the old style GPIO frameworks to those that are supported by the newer kernel. I think since kernel 5.11 there was quite a flag day in terms of how the pin headers can be addressed. So I've ported 3, but there's a ton to do. So, but I want to go through each of those devices and slowly bring them up so we can get to the fun stuff like the handhelds and the PlayStation 1 with the built-in LCD and stuff like that. Right then, I'm sorry if I've missed some of these comments, but I see this one from James. So James says, awesome. Well, thank you very much. That's very kind. Like I say, it's not down to just me. Dave is literally the expert in the room here at the moment, and I owe a great debt to all of the hard work that he's been doing in Ubuntu to make this possible. But he wants to return to the F2FS point. SD cards and USB sticks don't do wear leveling typically. This is true. Hence why they wear out, and F2FS is a better file system and faster for that. Yeah, okay, so I agree with a lot of that. I don't know how Ext4 competes with F2FS on that these days. Certainly, I made a case whilst I was at Canonical to add F2FS to one of the options for installing, because, you know, with SSDs being mainstream now, most people doing an install are installing on some sort of, you know, solid state media. I think for Retro Home, I'm definitely going to switch to F2FS for no other reason than learn something in the process. So yeah, thank you for your feedback. Stick around. We'll adapt that in a future build of Retro Home and see how it works. Maybe we'll have a little think about how we can do some file system benchmarks for that, because I think the common use cases on a Pi are going to be the SD card, a USB stick, and an SSD. And I think with this device I've got here, I've got an SSD, a SATA-based SSD on the, attached inside the Desk Pro case. Obviously, I can use the SD card front and the back, and a USB out the back, so it should be possible to test all 3 scenarios. Right then, send your pull requests and bugs here. I appreciate that this is a pretty terrible README, because it's basically my notes on the bootloader configuration, where I just went through the various Ubuntu bootloaders for the different versions in order to figure out what the appropriate options to borrow were. I suppose what I could do is this. We could do this. We've got think it's Raspberry Pi. No, it's not that. It is, here we go, that page there. Copy that. Let's do this at least. Because that's technically where you're going to get the downloads from. So we'll put that in there. I will fancy up this this page at some point. But if you're looking for an alternative, almost identical to this, with the exception it will be much closer to this, is Retro Home, which has a build script, which is going to work a little bit differently because I'm going to build some of the device configuration into separate deb packages and have those published in a PPA. But you'll see a lot of this process is almost the same. And I'm going to try and get these two build scripts to converge as best as possible. But this has to work a little differently because it's kind of a different device. And it supports, or will support, these different cases. And for each of these different cases, there may be a different GPIO driver, in air quotes, to access the facilities of those cases. And I think starting next week, this is what I'm going to be mostly focusing my attention on, because I am champing at the bit to play some classic retro games, and I would like to start getting some of these units up and running at home. I've been talking about putting a few in the front room to play on. So there's Retro Home as well, which is also a Raspberry Pi build script, and we now have access to this one. So I hope you'll find that useful. So have I covered everything? I think I've covered everything. We've looked at, tested the build work, which it does now. I think what we could do is we could actually kick off a little job here, couldn't we? We could go over here. Let's do this. We'll just adapt this image here. We'll drop the beta. We could do two things, which is only do the image in the compress stage, and that'll actually produce us the image from what we've got in the build cache. So let's just do that. So that will generate a new image without beta in the name, and compress and sign it, hopefully. And once that's done, I can add the configuration in for our mate chef and kick off the build process for the mate chef as well. So I'm just looking at, wow, goodness, why is this so complicated? That one, there we go. Let's move back here. Why did I want to look at this screen, I wonder? I wanted to look at this for some reason. I can't remember why now. Okay, anyway. Oh yeah, that's why. Okay, good. Right, so that is doing the build. It's now doing the compress, which will take a little bit of time. I can hear the fans have just spun up in this machine whilst it does that. XZ is quite an expensive algorithm, particularly for compressing. I'll move the Pi keyboard out of the way so I stop typing on the wrong one. So hopefully that was interesting. I will be interested to see if anyone forks that and makes another Ubuntu derived OS. You could make anything really with that. Let's have a look here. So its only name says, oh, and looking back at some notes, sudo apt-get install helped with GPU acceleration for 32-bit Chromium. Yes. Yeah. 32-bit Chromium running on ARM64. Is that what you're talking about there? I think I may have missed that point, but I think that's maybe what you're shooting up. Thanks very much for the follow. I appreciate that. You don't need Mesa Dev. Mesa Dev doesn't do anything for you. That is literally header packages. It will pull in all of the user space stuff as well, but you don't need Mesa Dev to actually get any performance improvements. Just install the right user space libraries. Okay, so there we go. We've got our... Oh, it didn't find my Okay, I'll have to re-sign it, but we've got a compressed image now. Oh, okay, here we go. What's looks like that. Sorry if I've nerd sniped you, Dave. That wasn't my intention. So Dave says, on the ZSwap issue, just fired up a fresh jammy card. Swap file does appear to get created successfully, and ZSwap is enabled, but only with LZO because of the missing bits in. Okay, so it is created correctly. So I'm going to go with what I have because it's tested now. And I think, but what I think I'll do is I'll adapt to the systemd units that you have in Ubuntu for a subsequent build when I do the 0.1s, because I think that's the more elegant solution. But thank you for confirming that swap is created and enabled correctly in Ubuntu. I will remove the words in the README of the project that I've just made public that contradict your statement, because thank you for checking. And It's Only a Gnome says, yeah, it was 32-bit Chromium on 64-bit Pi so that you could get access to the Widevine support. Yeah, that's an interesting... I'd never thought of doing that. That's, you know, now you mention it, it's kind of... this isn't disparaging, it's kind of obvious, but that's a really good idea. It's a nice way to work around it. I'll have a think about that and see if we can do something similar. The reason I mentioned Vivaldi is that one of the Vivaldi developers has a gist published which extracts the Widevine module from one of the Chrome OS images and injects it into the right places. So that's kind of a handy tool to simplify that process. King Egypt says, is there a Kubuntu image? I don't make one, but you could create one now. If you fork that Ubuntu Pi thing, I think it would be possible to create a Kubuntu image. Of course, you're open. I've just done it. It swirls. So here we go. Here it is here. It's under an MIT license. And this GitHub repository is now public, and it was private. As you can see, I think it looks like I created it maybe a couple of years ago. I moved it out. It was in a Git tree in Launchpad, so effectively undiscoverable, and I moved it here whilst I was working on it. So here's the script. Anyone can fork it and build from it. No, correct. There isn't. It's only a GNOME. The Widevine support that I'm referring to, their little gist, is for ARMHF only. So I was building on what you were just saying about running an ARMHF browser inside a 64-bit OS. But the reason I was interested in Vivaldi is for Retro Home, which is only ARMHF, because of the architecture that the projects that I'm building with, which is Ludo and RetroArch, they only have builds for ARMHF. So that's a single architecture project. So hopefully that clarifies that point there. Right then. So we had that build running. We've got this done.
Thank you for the follow, Select Reformed.
Thank you very much for the follow. I appreciate that. We keep our little tuxes at the bottom of the screen there, the hype train moving. So now that's done, what we'll do is we'll bring up the code editor and we'll do this. We'll enable all stages, and we'll actually just go here. And we will change this to ARMHF. And then we'll start a build. And this will build the ARMHF variant. And this is starting right at the very beginning, bootstrapping thing. We don't need to sit here for the 45 minutes or so that this will take. But this is building the ARMHF image, and that's so I can get both of these images uploaded to the Ubuntu MATE downloads page, I'm guessing sometime this evening. So hopefully by the time I do my next stream on Friday, these images will be out there and downloadable, and I'll let the internet know they can come and grab these things. That moment when the music stops and you wonder what's going on. Right, there we go. Sometimes I have to be careful because sometimes the music skips to the not free stuff that doesn't get copyright strikes and what have you. So, Takov says, I'm really waiting for, Minic 3 release. It's possible to use Popey's voice for TTS, for Atom. Ooh, that's interesting, isn't it? That sounds like a project. Maybe a project for 8-bit verses. Maybe a project for 8-bit verses. That could be appropriate. Right. Good idea. So we're now building the ARMHF image. That'll take... Popey says, God no. It's very emphatic. Very good. Yes, all of the quality memes are coming along now. I can't select single word responses, unfortunately, in featured chat. But King Egypt is making a reference to what are beans.
Thank you for the follow, Sopium.
Hey, Soapy Ham, thank you very much for the follow. I appreciate that. So we're looking in pretty good here. Let's just have a little think. We've got our image. This is the image that we just built, so that's effectively the same as this beta 1 image, but you know, and there it is compressed. And oh, it did hash it. That's good. Okay, so I just need to re-sign it, so I'll sign that after, and then I can get those uploaded. And here is the build directory. So here are the cache layers for Ubuntu MATE for each of the build stages, and as we can see, we've got the ARMHF build running at the moment. It pre-creates the cached endpoints, but we should see in here, this one, you know, is starting to get constructed as a result of this running here at the moment. So we're in pretty good shape, cooking on gas in fact. So there we go. There will be versions of Ubuntu MATE available for download very soon. And like I say, I mean, what do people think about this? On Friday, I'm thinking I'll bring in the entire collection of GPD devices in my backpack. I get them all out on the desk here, and we effectively go through like a similar process very quickly, bring up each device with a build of Ubuntu MATE 2204 for each of the GPD devices and confirm that that's all working. And then I can get those images uploaded to the Ubuntu MATE website as well. Hello, Yannick. Oh my gosh, lovely to see you again. I hope you are well. I haven't spoken to you in such a long time. So welcome back, and lovely to see you again. I know you've been busy. But yeah, lovely to see you around again. So, yeah. So yeah, I think Friday we'll do GPD stuff. Well, all things considered, I'm pleased to hear that. I'll try and catch up with you properly, Yannick, after, you know, not on stream and all the rest of it. I'll get in touch. Maybe we can have a chat at some point, because I've not spoken to you in ages. I actually just had a hiatus here for a few months because, oh well, I was not well and then super busy with work. So I'm now returning to a regular schedule of doing fun stuff in the mornings. But yeah, it'll be good to catch up with you. So this build is cooking along here. And one of the things Takoff and I have been discussing is taking this build script and maybe integrating it in some kind of self-hosted CI/CD platform to automate the build and publication of Raspberry Pi images, which is slightly complex in that, as I've explained, it builds inside a container, so we can't use Docker to build these images. They would have to be in a VM or on the metal of something. So yeah, that could be a tricky little project to tackle at some point. How do we like build whole operating systems in CI/CD? Yeah, so that's something we might have a stab at some future date. But for the moment, for iterating on Retro Home, actually building locally using this albeit primitive cache system is desirable whilst we iterate on these different devices. So King Egypt says, yep, they're up for some GPD fun. Okay, so I think we'll do that Friday then. And It Swirls says, so like, would I get a GPD? So like, I would get a GPD, but I have a Raspberry Pi. Okay, I'm not sure what you're driving at here. Well, whether a GPD device is worth buying is obviously a decision only you can make based on budget and
Thank you for
whether
the
it's
follow, Merlin
useful
and
to
Solomon.
you. Hello, Merlin and Solomon. Thank you very much for the follow. I appreciate that. But yeah, I've got most of the GPDs. I think all but one. They were going to send it to me, but everything's gone quiet over at GPD recently, so I've not got one of them. But I'll get them all built for 2204. It's a very different build process, that one. It actually takes the existing image of Ubuntu MATE, the official desktop image, and just injects a couple of configuration changes into the boot environment to cater for things like touchscreens and screen rotation. So the build process is significantly quicker. So I think I'll pre-generate all those images to save some time. I'll pre-flash them. In fact, I wonder if I've got enough USB sticks. I might have to bring in more of these from home, one for each, and maybe label them. I think I might have enough, one for each model, and then we can quickly test them and go over each of them. But the newer ones are quite decent. Yeah, that's a good point, isn't it? Yeah, King Egypt says, can't help myself around small computers. Yeah, I'm the same. A cute small computer is difficult to pass by. Yeah, I agree. In fact, something I should really take a look at now is I've got the Pinebook and the Pinebook Pro. I should really take a look at seeing if I can get like an official Ubuntu MATE going on those. I know there are people in the Pine community that have done MATE spins, but I'd be interested in seeing that for myself, and it could build on this very script that we've got here in terms of how to do it. Yeah, so I remember this. Dave's desk is like an Aladdin's cave of gadgets and technology.
Thank you for the follow, Toothless Viking.
Particularly for Raspberry Pi stuff. Thanks very much for the follow. I appreciate that. And what's this? So Takov is suggesting cross-platform Docker Builder is not that complicated. Yeah, so the only complicated thing is this, Takov, that these Raspberry Pi build scripts are run inside a container, and I imagine it may be possible, but I don't know how to make a systemd container function inside of a Docker container. I'm sure it's possible, but I haven't researched it. But that would be my first thought about like whether that's possible or not. I know we can do Docker in Docker. Maybe we could migrate the build scripts to Docker. I'd rather not do that because I trust these. I know they're reliable. But yeah, we can certainly look at our options. And Yannick says he's the same but with microcontrollers. I found a bunch of Raspberry Pi Picos and what have you. Yeah, Yeah. I've never got into the microcontrollers, but there's a friend of mine, Will, who's on the Late Night Linux podcast. He loves a good microcontroller as well. In fact, he covered on a recent episode like alternative operating systems for like proprietary devices. So open source firmware for microcontrollers found in proprietary devices to turn them back into sort of a managed device after the companies that made those devices have sort of done the bad thing to their customers. Right then, so Toothless Viking says, I always find it a bit funny to hear people say mate. Is it mate or mate that you're quoting there? I thought it was just like the British Australian way of saying hey mate. Yeah, so yeah, a lot of people do. I don't care really. It's mate. It's from the beverage, the South American beverage is where the name comes from. So technically it's mate, but mate works. In my head, when I'm reading, my inner voice says mate. But when I speak, I try to say the names correctly for the different projects. Okay, so well this script's going. Let's just go back here. So all of this build script stuff is available here now. It's all open up and ready to go. So I will be interested. Come and join our Discord. So wimpysworld.io/discord. And if you build something your own, like Ubuntu for Raspberry Pi, based on a fork of those scripts, do let me know. We've got a channel in there specifically for Raspberry Pi stuff. So let us know what you make. It would be interesting for me to catch up with like what other people have made deriving from those scripts. I'll be happy to showcase any other projects that get spin-off from that. Thanks, it swirls. Yeah, so there's, and I need to work on I was thinking of doing some sort of voice recognition, so when I say like Discord, it automatically plays like a Discord call to action animation in the stream. I think that would be some next level stuff in OBS to just have it, you know, context aware OBS stuff. I have seen some examples of voice controlled OBS studios, but there we go. Well, I think I'll say thank you very much everyone for stopping by today. I hope you found that interesting and useful. There's a new script in the world for you all to have a play with now. I'm going to be back on Friday morning, and we'll take a look at all of the GPD devices and getting Ubuntu MATE 22.04 up and running on those. And also tomorrow I will be streaming at 8 PM UK time. That's 3 PM Eastern time in the US. I'm going to be running over the 5 best security practices for production ready containers. So I gave a talk at the Comp42 SRE conference last week, and I'm going to do a rerun of that, but a little bit more interactive. It's actual practical tips for improving the security of your containers, significantly improving the security of your containers. But it's not a thought piece, it's actual practical things you can do, and I'll be looking at creating your containers using Distroless and Alpine and Ubuntu and Debian, looking at the relative sizes, the security profile of those different techniques, and actually making sort of an objective decision about which is the best base image and container construction technique to get the best possible outcome in terms of an optimized secure container. So I will be doing that on twitch.tv/slimdevops tomorrow evening UK time, 3 PM Eastern US time. So go and get subscribed over there and join me for that. I won't just present the slide deck, I'll actually dive into some of the configuration and how-tos as well. So hopefully I'll see you there, and if I don't, hopefully I'll see you back here on Friday for some fun with GPD devices. But thank you all for coming everyone, and I look forward to chatting to you again soon. Bye for now.